for coming. Everybody looking forward to the celebration tonight, yeah? Okay, that's good. No roller coasters or free food for the next half hour, though, unfortunately. But hopefully, myself and Rich will give you some information on our journey to SharePoint Online. Just a bit of a warning. This journey starts non-technical, but then builds the bit of technical stuff towards the end. So stick with us if you're interested in the technical stuff. My name is Eamon Hegarty. I'm a development manager for Primerica Systems in Ireland. So my job really is to manage teams of people to deliver products. Now, we're a wholly owned subsidiary of Prudential Financial based out of Newark, New Jersey. And probably the biggest team that I manage looks after Prudential's intranet. And that's going to be the bulk of this journey today, is talking about the intranet. Now, alongside me, I've got Richard Fisher, who's the solutions architect of that team. Richard, do you want to briefly introduce yourself?
Yeah, hi guys. So I'm Richard Fisher. I'm a solutions architect at Primerica, currently working on their new digital employee experience. And I'll be talking a bit later after Eamon about some of the technical aspects we had to consider to ensure we were building quality into the product right from the beginning and ensuring that we built a platform that can adapt to change. So I'll be taking you through our journey a bit later, but for now, back to Eamon.
Cheers, Rich. Okay, so Prudential's intranet, for as long as I can remember, it's been on a Java platform. I don't want to mention the vendor's name, but I'll give you 3 letters, A, B, and M, so you can work it out for yourself after that, guys, all right? But it's grown to between about 40 and 50 sites, depending on your definition of a site. It gets about 20 million page views per year. And we've got actually 3 Scrum teams supporting it at the moment. So, you know, it's a big effort. I suppose the main real estate, and it's something that's been it's talked a lot about in the conference this week, is the intranet homepage. So Prudential's got 55,000 domestic employees. So that homepage is like a really valuable piece of real estate. Now, our homepage, which is called Vision, gets about 12 page views per second at the peak times, early morning and early afternoon. And we launched a new version of the Vision website on the IBM portal in April 2017. And we've seen engagement go up 86% with that new version. So I know Naomi Moneypenny was talking about engagement and corporations trying to engage their employees a lot more these days. And that's absolutely vital for what we do, and it's what senior leadership give us the money to do these things for, is to increase engagement, increase collaboration, and build that corporate culture that all big companies are looking to build. So I suppose why am I on a MS Ignite stage talking about an IBM platform, but we changed in May 2017. It came down from the top to say, you need to take that entire intranet and you need to shift it to SharePoint Online. So nothing like a challenge. But they also said, we need you to do it by the end of December 2018, or else the company will have to buy millions of dollars of licenses that they don't need to buy. So nothing like a bit of pressure as well. But we've seen it as a challenge because, you know, some of the code that we're dealing with in the Java platform has been around since 2001. And we knew agility was going to be really important to us because we didn't know the platform as technologists. We were new to it. Our product owners and business users didn't know the platform either. So we were going to have to try some things out. We were probably going to go down some streets, have to reverse back out and try and go down another avenue. And we've certainly done lots of that over the last 14, 15 months or so. So I think what we're going to do is we're just going to break this presentation down into a couple of bits. I think the first bit, I just want to frame the agility challenge, because I think we overlook it quite a bit these days, and it comes back and bites you. It's certainly bitten me over the years. So, and then secondly, I want to just talk about our response to the agility challenge, and that breaks down into 4 bits. The first one's people. This is where the non-technical stuff comes in. People. The second one is architecture and design, which is why Richard is here as well. The third one's metrics, and the fourth one, which Richard's going to talk about, and it's going to represent the bulk of this presentation, is what we're calling agile engineering. So let me just jump into the agility challenge, because I think it does frame our journey and this talk for the rest of the time we have. So imagine a situation where your product owner comes to you, or the business comes to you and says, I want to go from A to B more efficiently, right? Sorry, this is about 101, but stick with me. This is like Steve Jobs saying, the human's the most inefficient animal in the world, but give him a bike, he becomes the most efficient, right? So iteration 1 of your product, you go with a scooter. Product owner comes back and says, the scooter's pretty good, but it's not very good over rough ground. So you try again, iteration 2, you build a balance bike. You make those wheels bigger, you fill them full of air, you add a nice comfy seat. And the guy goes, yeah, it's good, but it's not so good over long distances. So iteration 3, you try again. You put the tires and wheels bigger, you add brakes, you add drop bars, you add pedals. All of a sudden you end up with something that looks a bit like a road bike, right? So lots of change, and the product's constantly evolving. And it's our job as technologists to keep up with that change. Because if you don't, you end up in the big ball of mud. Or I've also heard it called spaghetti code, shantytown development, call it what you will, but I think we've all been there, right? So what we really need to do is we need to avoid that, because what that does is it strangles your agility. You'll end up with very unhappy product owners and business users, and there's no way of backing out of it. So you've got to stop that technical debt building up from the start, which is very important to us. Now, I mentioned that being the agility challenge in our response. We had 4 things. I think the first one was people, right? So I just want to talk about people. And I suppose my job as development manager, I've got to look after and hire people, so it's important. I think it should be important to you as well. So on the screen, we've got 3 photographs. Okay, the first one shows a formal ceremony. Looks like user story planning, right? Aislinn's there at the board. She's engaged in the team. She's trying to work through how the product's going to look. The second one, the bottom left, that's Phelan, right? He's one of our senior engineers. You can see he's got his headphones on. He's immersed. He's coding away. He may as well be wearing a T-shirt saying, "Do not come near me." He's got his headphones on. He's holding his coffee cup. I don't know why he's holding his coffee cup. I mean, we don't steal each other's coffee cups, but it must be his kind of thing, you know. So, and then the third one there is Austin and Joseph. So Austin's a junior developer. Joseph's a senior developer. They're obviously working on a piece of code at his machine. So again, an informal example of collaboration. I suppose the question would be, which one is more important? I would argue that all 3 are equally important. Now, as a younger manager, I would have thought bottom left is more important, because you've got to have guys who can do the work, right? But technology changes that fast. You know, if you're good at something, you probably have to learn something else pretty quick and be good at that too. I think you've got to bear in mind as well, we might be in Florida, but we're not trying to land the man on the moon here. Software development is complicated, but I think you need good people who can work with other people as well. And this is not just about having nice people for the sake of it. It's absolutely fundamental to stopping technical debt building up, because there's 3 things you need to think about. The first one, you're going to be under pressure. We're under time pressure. We're working with a new product. Under pressure, sometimes people don't react well. They've got to, because they've got to work together to build a product. I think the second one is you've got to refactor each other's code. I mean, you've seen how we went from a balance bike to a road bike. Now, the chances of the same developer being available to work on that small wheel on the scooter to the big wheel on the road bike, there's probably very little chance, right? You're going to have to share that work between team members, and that causes friction. You know, developers don't like other people picking up their code and making changes to it. But it has to be done, which is why collaboration is also key. I think the third thing, and the Azure DevOps stack is brilliant at this, you've got to peer review code before you allow it to check in. Now, we've got mandatory peer review, so nothing can go in without a peer review, and that makes such a difference to our quality. Now, Rich has some figures later on the number of merge requests going into your trunk, but you're literally talking about hundreds of crucial conversations between developers every month. So you need people that can work together. And you've got to watch out for those anti-patterns too. I think I've hired them all. You know, the hero, I'll go away and do this over the weekend. Don't worry, I just haven't got time to talk to anybody about it or, you know, peer review it. Just be careful of those guys, you know, because when they leave in 6 months, when they always do, somebody will turn around and say, well, who wrote this code? Who hired the guy to write this code? And you have to go, well, it was me. And the second one is, you might recognize yourself in some of these. I think I'm in there as well. The tortured genius. Tortured genius, you know. He's normally introduced to you by somebody saying, this guy's absolutely fantastic at his job, but maybe doesn't work too well with people. And, you know, you normally have to lock him in the room in the corner and slide the requirements onto the door. But I think just the way we're building software these days, with a focus on products, on vision. I hear Microsoft talking about it a lot as well. You really have got to have people that work together, because you've got to refactor your code as you go to sustain that level of change that the business want. So that was people. Then the second one I see as being really important is architecture and design. I'm going to have a bit of a pop at the agile movement, because I think the Agile Manifesto was written by people who are into XP, software engineers, for software engineers doing software development. But it's almost been hijacked by Scrum Masters and Agile coaches and all these people from the Agile industrial complex that, think building software is just all about process and ceremonies. I don't think it is. I think you've got to put architecture and design back in the center of what you're trying to do. And the thing that captures this most for me is Sprint Zero. You go to Scrum School and they talk about Sprint Zero and they ask you what it is, and they say, well, that's where you write all the user stories to keep you going for 2 or 3 sprints, right? Well, is that all it is? Is that all it is? I don't think it is, because we actually used it to not only write our user stories, we've done that as well, but we made sure that our non-functionals were front and center, and moving to a new platform like Azure and SharePoint and Office 365 is equally vital. I mean, in our Sprint Zero, we outlined the high-level solutions architecture. We outlined the high-level information architecture, which is absolutely vital in SharePoint Online. We've done our Azure DevOps pipeline, CI, CD. We've done our unit test framework for our TDD. We set up our source control and our branching strategy. We defined something called the the Developer Manifesto that we created in OneNote, which was all the best practices for the developers that we wanted them to follow. And we'd done all of that before Sprint Zero ended, because we wanted to make sure the technical debt didn't build up from the start. And I think that's so critical to building software that can flex. I just draw your attention to the photograph here. We've got one of our product owners, Pete, who's at the board working on an early wireframe of what our vision homepage would look like in SharePoint. And you can see we're focusing here on functionals, right? How does it work? What happens when you click here? We also got Ben in the picture, keeping a close eye on another product owner. But that head closest to you there, closest to the camera, that's John Carley, who works for a Microsoft Gold partner. He's CTO of a company called Spanish Point. And he came in and gave us a lot of that knowledge we didn't have at the start. But you can see he's keeping a close eye on the 2 guys at the board. And off to the left and off to the right, you can see that we've stuck these pages to the wall. Now, those pages are our low-fidelity first draft of our information architecture, of how all of these sites is going to hang together. So I just want to point out, that's from our Sprint Zero. We're already thinking about our information architecture. So please consider non-functionals along with your functionals. All you technical people, this is a rallying call to step up and reclaim the soul of agile engineering. So we certainly find it important, and that's lessons we've learned from the past. So that's people working together, and that's architecture and design. The third thing I just want to focus on is metrics. Like, I defined a metrics catalog that we were going to use from the very start. I challenged the guys to record these from Sprint 1. As you can see, I've been tracking some of these since 2012. But you need to keep metrics that focus on quality and agility, or else you'll not detect those smells. That's functional debt building up, all right? Because remember, you'll get away for 10, 15, 20 sprints, maybe even a year and a half, but eventually it'll come and strangle you if you're not watching it. And just quickly go through each one of those. Top left then is lead time. So lead time is the amount of time that the business asks you for something, even a one-liner, to it's actually deployed in production. Now you can see back in 2012 in our current or old stack, that was 102 working days. Now I've brought it down to 38 working days today, but that took 5 DevOps guys, because that's an on-premise installation. It's got 17 portal servers, it's got 70 web servers. It takes a lot of maintenance. But I think with this Azure DevOps stack that we're moving to, I'm pretty sure actually, that we'll get that down under 20 days, because we will be released 2 or 3 days after each sprint. I think that's massive. And I think it's also worth calling out that I think we'll go from 5 DevOps guys down to 2 or 2.5. So big savings there. Now, I know that we normally don't get much of a rebound productivity-wise from switching tools. I know this is a Microsoft conference, but I wouldn't say it otherwise, but I really do think these tools are making a big difference to us. Second one I've got there is build time, right? So build and deploy time. As you're building your software, as you're adding more components, as your software is growing, you've got to keep an eye on your build and deploy time, right? Because as you add more stuff, it's going to take longer and longer, and that's going to take more and more maintenance to keep it at a reasonable level. And you want developers checking in often. If your build time's big, they won't. So keep an eye on that and make sure it's trending downwards. The third one then is unit test coverage. You can see it was 0 until we moved to this new stack. But Visual Studio and the Azure DevOps stack that we've got now, we were able to insist on unit test coverage from the very start. So we actually don't allow, tool stack doesn't allow developers to check in unless they've got 80% unit test code coverage. It just won't let them check in, which is brilliant for us. We couldn't do it before. Well, that's a big difference, and we're kind of hoping that's going to help us with our agility and our quality. The fourth one there is static code analysis. Again, plug it in and trend it over time. Make sure it's going the right way. I mean, that's an objective model that you can use to say that your code base is sound, as opposed to you relying on going talking to developers and saying, did you peer review that? Is that okay? You can trend that over time. Now, we're using Endepend, which is available on the Azure stack for server-side stuff. I think we're using TS-Lint, right? We're
using SonarQube.
SonarQube.
Yep.
So, plug in whatever you need to record the metrics. You need to prove that your quality is good. Don't rely on somebody's opinion. And the fifth one is percentage of QA automated, but really this is trying to say, how big is your QA regression window? If it's too big, you're going to lose your agility, right? In our portal stack, it was actually 2 weeks of manual regression testing before we could go to production. That was too much. What we had to do was queue up 3 sprints worth of work and then send them to production after that QA regression. But so that was killing our lead time. That's why it was stuck there at 38, 40 days. So again, challenge your QA guys with the Visual Studio stack. I mean, our guys are all using Visual Studio Enterprise Edition, which ships with the QA software, the testing software. Challenge them to automate as much as they can so that regression window is as small as possible. And that's why I think we'll be able to go after every sprint to production after maybe 2 days of regression testing. And we're trying to bring that down to hours. Again, I think that's a bounce from the stack, switching to the Microsoft stack. And the final one, so I mentioned agility. The other one is quality, right? So the proof of the pudding will be in how many post-production defects will you have after you go live, and trend that over time, right? Because there's no point in you charging into production if you're delivering poor quality stuff to your customers. So trend your defects and make sure they're going down. So in summary then, have people that can work together to refactor code, reclaim Sprint Zero. All of you architects, designers, tech leads, step up and challenge your product owners and your scrum masters and your agile coaches and put architecture and design back at the center of what you're doing. And the third thing, have your own metrics. Make sure you can trend and show positive results so you're picking up any smells of technical debt and you're making sure you're addressing them. And now the final part of this presentation, we're going to talk on the fourth part of that response that we see, the agility challenge, is what we call agile engineering. And for that, I'll hand over to our solutions architect, Rich.
Okay. Thanks, Simon. Thanks for that insightful talk on creating an empowered team and reclaiming Sprint Zero. So who has heard of the big A, little a syndrome? No one. Okay, so well, you're going to learn something today. Big A in Agile is the Agile project management. And often in the Agile world, that gets all the focus. And what is the little a? The little a is the Agile engineering side. So those technical aspects that you need to do to ensure that your code is able to adapt to this changing environment and extend and change without introducing risk into your code. So we knew this was going to be a challenge for us. We knew even as our organization, too much focus has been put on the Agile project management. So let's look at some of the challenges we faced early on. We had 1.5 years to implement this new product, and it wasn't just a lift and shift from IBM to the Microsoft stack. It was reinventing that employee engagement, reinventing that employee digital experience. So we had 23 sprints to do this in, which is a very small time frame. Prudential is a global, multinational company spanning 5 continents. They have more than 40,000 users, and we had to move 40-plus site collections from this IBM stack to the Microsoft stack, and each of those sites had specific requirements. We knew we had challenges around complexity. Our product owners were shooting for the stars. We knew that we would have complexity around the ecosystem. Within Prudential, it is such a big organization with such complex processes and red tape. We knew we'd have to navigate that. We knew from a technical point of view that there would be a whole lot of complexity. We were targeting a new platform, a software as a service, SharePoint Online, a new framework, the SharePoint framework. We knew that we would have to deliver the solution on multiple different clients and still have that same usability across all those clients. We knew that there will be challenges around governance. Again, multinational corporation with a lot of red tape. We had enterprise architecture review boards. We had enterprise standards we needed to adhere to. We had ISO. We had legal and compliance. And we knew that probably the biggest challenge for us was we were no longer in the driving seat of the platform. The platform, the infrastructure, we weren't in control of it. The updates to the platform, we weren't in control of it. So we had to be agile enough to actually adapt to those challenges. So let's have a look at what we managed to achieve. So let's start at the end, and then we'll work our way back on how we managed to achieve this. If we look at the number of tenants we're targeting with this solution, at the moment we have the solution running on 3 tenants. In the second quarter of 2019, we plan to deploy it to additional 2 tenants. We've got 252, well, more than 252 communication sites, and that's a testament to the flat information architecture. So instead of subifying, we're hubifying. We have 0 out-of-the-box web parts on our main site. Now, you might think, well, that's an amazing achievement. Or on the other hand, you may think, wow, the heck didn't you just use the out-of-the-box stuff? Well, we were early adopters of the SharePoint framework. We started off at version 1. And at version 1, the out-of-the-box web parts just didn't do what we wanted it to do. It wasn't able to give us that personalized user experience. So we went out and we've created 24 customized web parts in the same time that Microsoft has delivered 33 web parts. So we're operating at scale. We have more than 1,000 backlog items created in the last month. Testament to our product owners going to bed at night and dreaming about these fantastic new features. And when they wake up and they join us at our next grooming session, you know, they bring to us all these lovely new changes. Pull requests, 158 pull requests in the last month, 1 pull request every hour. Why is that important? Well, our developers are checking in their code regularly, and that code is being integrated into the technical environment through these quality gates that I'll speak about a bit later, ensuring that we have working code on a regular basis. We have 2 SharePoint main packages. We have 6 extensions, otherwise known as the application customizers, which is helping us deliver this personalized experience. We have 15 shared modules, and underpinning all this code, we have over 1,600 automated tests, ensuring that the code that has been written is delivering what our customer wants. So let's look at the ecosystem that we built to enable this product and support this product. With regards to requirements, our product owners are using Jira to create those epics and stories at a very high level. And once that's been created in Jira, and we got a good understanding of what the product owners want, we take those stories and we move them into Azure boards, which used to be VSTS. for the team to swarm around and use the Scrum framework to actually work out those stories and implement them. We're using Visio for our design and our architecture models, and we're using OneNote and Teams for our collaboration. With regards to the deployment environment, we're using this new framework, and we knew that it would be a challenge. We knew that it would be complex. We're doing a lot of the compute on the front end instead of doing all your compute in the back end like we used to do in the past. So we're using the new SharePoint framework. We're currently on version 1.5.1. Microsoft is on 1.6, so we're closely following their releases. We're using the PnP libraries. And we're not only using the libraries, but our development teams are actively contributing to the PnP community. We use Visual Studio Code and Yeoman for the front-end IDE. We're using React and TypeScript to create the web controls. We're using Node and .NET as our runtime environments. And we're using Gulp for our front-end builds and Webpack for the front-end packaging. Now, our packaging has got to the point where it's getting too complex, and we needed to look for a packaging system that can help simplify. And that we've decided to look at Rush. Rush allows you to abstract all that packaging and manage it a lot easier. So if we look at the developer, he pulls down a feature branch. He makes his changes, he codes, he implements the functionality as is required. For him to get that code into our pipeline, he needs to create a pull request, as I mentioned previously. That pull request kicks off a build on our pre-flight. Within our pre-flight build, we are running static code analysis tools, SonarQube with a TypeScript plugin to analyze the code based on best practices and identify technical debt before the code gets into the development branch. Once that is passed, the next step is that a team lead needs to have a look at that code that's been written and make sure that the code adheres to our design principles and our design practices that we are wanting to drive within our team. And only once that is approved does the code eventually merge into our development branch, which kicks off a build and release and deploys the code to our development environment. At that point, our testers have the ability to click a button and say, yes, we want to pull that code into the QA environment. But before they do that, they are writing their automated tests. And they're using Selenium to write the web tests. And hopefully in the future, we're going to be using Appium to write our mobile tests. So once they've created their automation test for the front end, they then click the button to approve the code to move to the QA environment. They run their automation scripts in QA. Once they're happy, they've tested everything, they've done their manual exploratory testing, then they are in control of moving that code from our development branch into our master branch, which kicks off another build and release, which releases to our staging environment. In our staging environment, our product owners and our users have a chance to interact with the code and say, yeah, we're happy, all good to go. And then once everyone's happy with that, we're now at a point where we have potentially shippable code. Now, underpinning all of this is team and pipeline collaboration. So our teams are collaborating using the Office 365 suite for internal collaboration, and for external collaboration, we're using the PnP community as well as GitHub. So that's the ecosystem that we built to enable this, the product that we're building, and to ensure that we can deliver working software on a regular cadence. Now, I want to speak about that little A that I mentioned right in the beginning, agile engineering. Agile engineering allows us to manage agility at the code level. And why is that important? Well, as soon as you touch any bit of code that has been written, and you change it or you extend it, you could potentially be introducing risk into your code. Now, agile engineering practices allows you to manage that risk, to ensure that when you change a piece of code and it happens to break something, that a test will fail and you'll be notified of that failure immediately. So what we've done, we've used the testing automation pyramid, which was initially popularized by Michael Cohen in 2009. And in essence, what it's saying is that the amount of tests that you're creating at each level is a pictorial representation of the pyramid. At the base, you should have most of your tests. These are unit tests. In the middle, you should have your acceptance and your integration tests, and which will be a little bit less. And then right at the top are your UI automation. Now notice how small the UI automation is. And the reason for that is each level enables the next level to facilitate what it needs to do. So at the bottom level, it's easy to implement unit tests. It's fast to run, and it's low cost to maintain. As you move up the pyramid, it becomes harder to create the tests and harder to maintain the tests and more expensive to actually run. So if we look at agile engineering practices that we can apply at each of these levels, the first is test-driven development. And what that does, it forces the developer to not just rush in and start coding, but to first interact with the testers, understand the requirements, think about the code design, frame out the specifications for the code, and then go and write the code. At the next level, we have acceptance test-driven development. And I think this is the least known level and probably needs the most explaining. And what I'll do in the next slide, I'll actually take you through an example of acceptance test-driven development. And for that, I'm going to need a helping hand. So I know it takes a while for people to get up the courage, so I'll leave that with you for now to think about that. And then at the top level, we're using QA automation to simulate the user interaction. I just want to bring a bit of focus on manual tests. Now, you might say that this pyramid is an automation test stack. Why would you have manual tests? Well, manual tests are not evil, believe it or not. They're actually very, very necessary, even in this modern day of programming. Manual tests allows you to uncover those unknowns, because you can only automate what you know. You can't automate what you don't know. So manual tests are those exploratory tests where you're going in and you're trying all new ways to break the system. And by doing that, you're surfacing requirements that you may have missed, and you're surfacing maybe business rules that you may have missed. So manual tests are still very important. Now, underpinning this automation pyramid is the Agile Engineering Foundation. Now, I don't know if you've ever thought of this, because I think a lot of the times this is just assumed to be in place. Because I've hired the right people, that's obvious. I mean, they've done that. But I can tell you now, if you do not think about your Agile Engineering Foundation, your testing automation stack is going to be very difficult to sustain it. Now, following this model ensures that your code is traceable, your requirements are traceable to lines of code. And I'll show you that in a minute. It ensures that your code is of high quality. And it also ensures that changes are done at a low risk. So let's look at acceptance test-driven development. Are you guys, have you thought about who's going to put their hand up yet? You've got about another 30 seconds. So acceptance test-driven development allows us to frame out the business requirements in normal business English. And we use the Gherkin language to frame that out. So if we look at it, we have a feature. We want to create a back-to-top button. And to create a back-to-top button, there are a number of scenarios that implement that. If we look at the scenario level, there is a structure that you need to create this acceptance test in. So it starts off with given a scenario. When something happens, then I expect an action or an outcome. Now, we can take this structure and we can implement this given structure in code. Now, do I have anyone that's willing to come up and actually help me? If no one's going to come up, then I'm going to choose one of my colleagues. Hey, there we go. Great. So let me, come join me here. Okay, so I'm going to give you the remote. Okay? Now, what I need you to do is help me prove that the requirements on the left have been implemented in code on the right. So all I need you to do is just read out each line one by one, and after you finish reading out the line, just click the next button. And, okay, so feature, back to top button. There's the code on the right that implements that feature. Scenario, use the back to top button.
Okay, do the click.
Click it again.
Given, I load a page that has back to top.
There we go. There's your one-to-one match. The next one. Given, I load a page, you actually skipped a step. Given I load the page that has a back to top, if you look on the right, what do you see? In code.
Yeah, I see the win is selected right now, but you mean the one above it?
No, given I load a page that has back to top, and then with the little red arrow is, given I load a page that has back to top. There's a one-to-one relationship between the requirement and the code that's been implemented. Go to the next one. When I scroll the page, on the right, what do you see?
When I scroll the page.
There you go. Thank you very much for your help. So, what I've tried to get out of that is, on the left, we have business English for your stories requirements, acceptance requirements. And on the right, you can see a one-to-one relationship between the requirement and what has been implemented in code. And I think that is pretty amazing. Where before, you never had that ability to actually prove that what the customer wanted, we've actually implemented in code. Okay, so let's have a look at that agile engineering foundation that I mentioned earlier. The first pillar holding up that foundation is agile architecture. Now, when I look at agile and I look at architecture, to me, initially, I'm thinking oil and water. These things just don't mix. Because I come from the traditional architecture environment where you sit on this high tower and you create all these fancy models, and then once you finish, you throw it down to the development team and you've never seen again. But I challenge you to look at the Agile Principle 9 and 11. Right in the beginning, when that manifesto was created and those principles were pushed out, right then, they were already speaking about how important architecture and design is. Now, architecture in the agile environment is made up of two parts. The first part is intentional architecture. And that is what Eamon was touching on earlier, which is looking ahead and figuring out what is required to create a runway for your Scrum teams to implement these stories on a regular cadence. The second part is emergent design. Now, emergent design is where your developers are following your TDD and ATDD practices, and the best design emerges over time. And how that happens is, during the sprint, you're developing code, you're using these practices, you're refactoring over time, and the best design starts to emerge. Now, they are not mutually exclusive. Emergent design needs to influence your architecture. And how's that done? Well, the architect needs to be part of the team. The architect needs to be part of all the ceremonies. And through that collaboration, your intentional architecture is refined and extended. Who here has seen the movie The Mummy? Okay, great. So I can use an analogy that you'll all understand. So intentional architecture, think of it as when that mummy comes out of the coffin, let's call it, or sarcophagus, it comes out as a skeleton. But it's not a stationary skeleton. It's a skeleton that's already moving. Now, that's intentional architecture. And think of emergent design as the skeleton is busy moving, muscles, tendons, flesh, eyes, ears start to form on the skeleton. And that's emergent design, influencing the intentional architecture. The next is engineering. So applying those engineering practices, looking at your coding standards, ensuring that your developers are writing code that not only they understand, but that every other developer that eventually works on that code can actually read it and understand it. Design principles and patterns. Using SOLID. Who here has heard of SOLID before? The acronym. Okay, great. So SOLID is an object-oriented principle that allows you to build code that's extendable and changeable without introducing risk. We're following the SharePoint pattern and practices, which put forward the best practices for the SharePoint framework. And we are using design patterns where relevant. I just want to call out, if you are going to use design patterns, use it where the value outweighs the complexity. Because design patterns, as great as they are, they inherently make your code more complex. And if your code's more complex, it's not as readable. So use design patterns where the value outweighs the complexity. The next pillar is source control. Now you might think, yeah, that's given. Obviously, we've got to use source control. But I think we need to understand why we're using source control and what are the advantages and what does it actually enable us to do. So first of all, obviously, it's version control. That's a given. But very important is it helps with your branching and merging strategy. Creating your feature branch, your dev branch, your master branch, and managing that complexity of merging the code through each of those pipes. Tagging. We're using tagging to tag all of our builds and all of our releases. And why are we doing that? Well, you can have targeted releases, and you can also manage hotfixes. So you've deployed something into production. Oh no, you've broken something. Now how do you roll back to that previous version? Well, the easiest way is you've tagged that release. All you do is deploy that last working release, and you've solved your problem. Policies. If you look at policies within version control, that's really around the pull requests that we've implemented. DevOps brings everything together. DevOps enables what you've done to fit together, work together, and move along each of the pipes till eventually it gets out into production. So we're doing continuous integration. We're doing continuous inspection to ensure that the code is of high quality. We're doing continuous delivery. What is important to note there, we're not following continuous deployment, and there is a difference. Continuous deployment means you've automated everything, and there's basically no human interaction. So once a developer does his check-in of the code, then it would run all the automated steps, all the automated tests, and eventually take it through each environment, eventually to production. Now, I don't know about you, but I'm one that likes control, and I want a little bit more control over that release into the relevant environments. So we're following a continuous delivery model where we have approval gates. So for code to get into the dev branch, a tech lead needs to approve it. For code to get into QA, a QA representative needs to approve it. For code to move out of UAT into production, our product owner needs to say, yes, we're happy with it. And I myself, as a solutions architect, needs to give that tick and say, yes, I'm really happy with this. It can go to production. DevOps allows you to manage your configuration across multiple environments. It allows you to manage your security and actually put your security right up front where it should be. And at the moment, I think the buzzword is DevSecOps. And that's where the security is going. Monitoring. It allows you to have visibility on all your builds, on all the failures, on all your tests. It allows you to monitor your releases, successes, and failures. And monitoring your production environment. So we're using application insights to manage the front end and the back end, and we are using Power BI to create those fancy reports.
Keep an eye on your time there, Rich.
How much time do I have left? Okay. So let's have a look at our automation journey. I'm not going to spend too much time on this, but I'm hoping you can learn from our mistakes. Now, we didn't go from 0 to hero with this automation journey. We started off with UI automation, where I think most people are, and we take our manual testers and we retrain them as automation engineers, and they fall into this Oprah syndrome of you get automation, you get automation. We all get automation. And as great as that sounds, it does lead to the anti-pattern of the ice cream cone, where you've got all this heavy UI automation on top. And we know from the testing automation pyramid that that's volatile and it's expensive and it takes long to run. So you are creating problems for yourself. So the next step in the journey is we focused on code coverage. Where there we were looking at writing tests for the code that's been written and focusing on getting our test coverage from 40 to 80%, as Eamon mentioned. But we were focusing on the wrong thing. We were focusing on code coverage. And that, again, sounds great, but we weren't focusing on building quality code. And that's where TDD comes in. Test-driven development allows you to think of the requirements, think about the design before you actually start implementing the code. And what we did there is we appointed evangelist. So instead of doing this top-down, we actually appointed an evangelist, which was a Radio Tech lead, and he actually went out and showcased test-driven development and proved the value to the team. So then the team could actually grab it and run with it. The next step was to look at regression. We have all these UI tests, but we can't integrate it into our build because it just takes too long. So we looked at implementing nightly runs. So we would run our UI tests at night. All the failures that happen would then be added to the backlog as bugs in the current sprint and then be fixed. And then the last step in the journey was ATDD, which I've spoken about, and I've shown you how that works. And I've shown you the real advantages of that. But the biggest advantage for me is that it brings your developer and your tester closer together. And if that's the only advantage of ATDD, and that's the only advantage you get out of it, I would say you've achieved a lot. So in future, we plan on automating our non-functionals, and we plan on bringing in our UI automation into our build. But to do that, we need to reduce the volume of our UI tests. So in conclusion, we managed to overcome the agility challenge by building an empowered team, which Eamon has spoken to, building a technical platform, building a technical ecosystem on a solid foundation using SharePoint Online, Office 365, and Azure, building a code base that can flex using agile engineering, and building a continuous improvement culture. And underpinning all of that are the 3 pillars of Scrum: transparency, inspection, and adaptation. Thank you very much for listening to my talk. I hope you've learned something interesting, or maybe there's something you can take away. If there are any questions, you're welcome to go up to the mic and pose us your questions, and we'll try to answer it to the best of our knowledge. Yeah.